Hi everybody, welcome back to Claudia's Math Classroom. Today we're going to talk about factoring special quadratics. So there's a couple of different kinds. We're going to focus on the difference of squares, factoring difference of squares, and factoring perfect square trinomials, and they can look different. So let me explain. We'll start with difference of squares. So difference of squares has a specific pattern to it, and it looks like this, okay? So a squared minus b squared. So we have difference, meaning a minus sign, and we have a square and another square. All difference of squares factor according to this pattern. So it's a minus b, a plus b. Now my habit is to put the minus first, but it doesn't really matter what you do. You can write it like this as well. It doesn't matter what order things are multiplied in, you're going to get the same answer. So this is the pattern for factoring difference of squares. Now let's see why that should be the way that it is. So let's take x squared minus 9. Okay, this is a perfect example of difference of squares. This factors into x minus 3, x plus 3. Notice there's no middle term. The last few quadratics that we've been doing have been of this form. ax squared plus bx plus c, and a, b, and c were all non-zero numbers. There was always a value to them that wasn't zero. This time b is 0, so if we wrote this a different way, it would look like this. It would look like x squared minus or plus, doesn't matter, 0x minus 9. So if we look at this in the way that we've been looking at the other factoring quadratics, what we're looking for is we're looking for a pair of numbers that multiplies to make 9, adds to make 0. Now, there's only one pair of numbers that does that for 9, and that's plus and minus 3. So if we take 3 and 3, 9, and we say, well, that has to be a positive and that has to be a negative, then you can see how we end up with these factors. Now if we take x minus 3 and x plus 3 and multiply it out, here's what happens. We get x squared plus 3x minus 3x minus 9. And so those middle terms, they're going to go away. And so we end up with x squared minus 9, just because plus 3 minus 3 is 0. Okay, so those go away. Let's see, so let's look at some more examples. How about this one here? So again, it's the same pattern. It's a squared minus b squared. The square root of the first term is 5x. We can put a minus or a plus, it doesn't matter. The square root of the second term is 8y. So when I'm talking about square root, you probably all know this, but I'm talking about the number and the sign, and the variable, as the case is here. We're talking about what would I have to multiply by itself to get that. So obviously 5x multiplied by itself gives me 25x squared. This little term here is a perfect square, and so is this term here. That's 64y squared, that's a perfect square. So again, the pattern is the square root of the first term minus or plus the square root of the second term, and then we write the same thing again, just with the opposite sign. And that one's done. And this one. So remember how I said that it's really important to try to find anything that's common to all the terms before you get into any factoring pattern. So for this one, we have a common 3, don't we? If we notice that common 3 and take it out, we have that. The 3 comes along for the ride, and we factor this according to the difference of squares pattern. And so we just end up with that. And finally, we have this one. Now what's different about that one? Well, it's got a plus sign. It's not a minus sign, right? So it's not a difference of squares. This is what you would call a sum of squares. And guess what? This doesn't factor, okay? If we say, oh, this is x minus 9x plus 9, if we multiply it out, we get x squared minus 81, okay? This is the minus times the plus isn't going to give us a plus, it's going to give us a minus. If we say, oh, then it must be x plus 9, or x minus 9x minus 9, that won't work either, because if we multiply these out, the middle term will not go away, okay? We're going to get x squared plus 9x plus 9x plus 81, which then becomes this. And here we're going to get x squared minus 9x plus 81, and then we're going to get that. So this isn't going to work. This does not factor. Okay, so don't try to factor sum of squares. If there's a squared and then another square here, or any number here actually, that's larger than 0, so x squared plus any number cannot be factored. Okay, there's got to be a middle term for it to even be possible. So that one doesn't factor. Okay, so that's it for this video. So tune into the next one where we're going to look at a different look to the difference of squares. Okay, and if you like this video, please give me a thumbs up, and please subscribe to my channel, and we'll see you next time. Okay, thank you very much.